Today we're going to look at another form of factorising, and we're going to be factorising trinomials today. So let's look at what trinomials are. So we know how to expand brackets. So if we have double brackets, x plus 1, x plus 2, we can expand these and you would get x squared plus 3x plus 2. And we know that factorising is when we're putting brackets back in. So if we were to start with this expression this time, okay, so we've expanded brackets to get this. Now we're going to start with our expression and we're going to end up putting it into double brackets. Okay, so we've factorised this, but we're going to learn how we get these double brackets today. So an algebraic expression of the form, so x squared plus 3x plus 2, where 3 could be any number, 2 could be any number, is known as a trinomial. And trinomials have 3 terms. So that's a trinomial. That's what we're going to be factorising today. So let's look at this first example. So we're going to factorise x squared plus 4x plus 3. And there's a process that we're going to follow. It might look quite confusing to start with, but I promise you the more practice that you do with it, you'll become a lot quicker at doing these questions. So it's a step-by-step process that we're going to follow. Our first process is we're going to multiply the coefficient. Okay, so this new word coefficient, that means the number that is in front of the x squared term. Okay, so we're going to multiply the coefficient of x squared. Obviously it looks like there's nothing there, but remember in algebra that would just be a 1, so there's a little invisible 1 there. So we're going to multiply the coefficient of x squared by the last term being 3. So we're going to multiply that invisible 1 by 3. Okay, so 1 times 3 gives us 3. Our next step is we're going to find the factor pairs of this number. So what two numbers multiply together to give you 3? Well, there's only two numbers and we've written them there, 1 and 3. So we're going to draw out a little table and write down the factor pairs, so it's 1 and 3. The next step we're going to do is, it's straightforward because we've only got this one pair, but we would find the pair that multiply, so the pair of numbers that multiply to give us 3, multiply to give us this number, so the last number, and then add together to give us 4. Okay, so we're multiplying to give us this number that we've multiplied to get, and then do the pairs of numbers add together to give us 4. And clearly 1 add 3 do give us 4, so that is what we're going to use. So we're then going to rewrite the first expression using these numbers, meaning our x squared term we're going to rewrite and it stays the same. Okay, x squared. We're then going to expand this 4x using our two numbers that we've just found, our two factors. Okay, so essentially we're breaking this 4x up into 1x, 1 being the first factor, plus 3x being that second factor there. And then the plus 3 stays the same. So let's just go over that again. X squared stays the same. We're splitting that 4x, this middle term, into our two factors of x. And then the plus 3 stays the same. Once we have done that, we're going to split this expression here right down the middle, like this. And we're going to factorise each of these sides of the equation using a common factor. Okay, so if we just consider this first part here, which we've got x squared plus x, we're going to factorise using a common factor. And here we have a common factor of x, so we take x outside of the bracket, x times x gives you x squared, then x times 1 will give us x. So that's why we've got x bracket x plus 1. So we've factorised the first half of our expression. We now need to factorise the second half by again taking out a common factor. Our common factor is 3 this time, so 3 and then just factorise like you normally would using a common factor. Taking 3 out, 3 times x gives us 3x, 3 times 1 will give us 3. Now once we've done that, we're essentially finished, but we just need to identify our two brackets. Our first bracket is the term that is in front of the first bracket and the last bracket. That creates our first bracket. And x plus 1 is our second bracket. These two brackets that we have here must be the same. If they are not the same, then you've made a little mistake somewhere. So then our final answer, so x plus 3 is our first bracket, then x plus 1 is our second bracket, and that is the final answer. And remember, you can always double check by multiplying out these brackets. So what we're doing again, following all these steps, multiplying the number in front of the x squared by the last term, and then you're finding all the factor pairs that make up that number. So this is a nice and easy one because there are only two numbers just now. And then you need to make sure that these two numbers, yes, they multiply to give us 3, but do they add to give us this middle term? And then they do, so we're splitting that up. And then we're splitting it down the middle, finding our common factor of both of the halves of the expression, and then we are identifying our first and second bracket. As I said before, this will seem like a lot just now, but I really want you to follow this step by step in the example I'm going to ask you to do just now, and then I'm going to go through some more examples after this. So pause the video here and try as best you can to factorise x squared plus 6x plus 5 using that first example. Okay, so our first step is to multiply the coefficient of x squared, which is 1, by 5. So multiply them together to give us 5. We are then identifying the factor pairs of 5. There's only one factor pair just now, which is 1 and 5. Okay, we are making sure that they do multiply to give us 5, and now they add to give us this middle term. They add to give us 6, which is correct. So we're going to rewrite our expression, splitting up the 6x using these factor pairs. So x squared stays the same. 6x, so we're going to split it up into 1x and 5x, and then our plus 5 stays the same. We're then going to factorise this first half of the expression by finding our common factor of x, so you should have x bracket x plus 1, then factorise that second bracket by taking out a common factor of 5, 5x plus 1. So we're essentially finished. We just need to write down, identify our first and second bracket. So x plus 5 make our first bracket, then x plus 1 will make our second bracket. And that is the final answer. So well done if you got that. And remember, you can multiply out to check that. So if you expand these brackets, you will get x squared plus 6x plus 5. Okay, example 2. So this time we're going to factorise x squared plus 6x plus 8. We're going to multiply the coefficient of x squared by that last term, so multiply them together. So 1 times 8 is 8, pretty straightforward. We now need to write down the factor pairs of 8. So what two numbers multiply together to give us 8? Well, we have 1 times 8, but we've also got 2 times 4 this time. So we've got two options. So we need to figure out what pair multiply together to give us 8. So we know that they all multiply together to give us 8. And what pair add together to give us 6. So 1 add 8 is 9, so it's not going to be that pair. But 2 add 4 is 6, so we're going to be using that second pair. So we need to have this pair for, the factor pairs that add together to give us this middle term. So now we can go ahead and rewrite it and split up our 6x into 2x add 4x. So our x squared stays the same. We've got plus 2x plus 4x, and our plus 8 stays the same. We then split it down the middle and factorise the first half using a common factor, and then the second half using a common factor. So our first half, our common factor is x, so we're going to have x bracket x plus 2. And then our second half, we've got a common factor of 4, so take 4 outside of the bracket. 4 times x gives us 4x, and then 4 times 2 will give us 8. And once we've done that, all we need to do is identify our two brackets. First bracket is going to be x plus 4, and then our second bracket is x plus 2, making sure that these two brackets are the same. And then our final answer is just x plus 4, x plus 2 in brackets. So again, can you follow this example and factorise x squared plus 7x plus 10? Okay, so multiplying the coefficient of x squared by that last term. So 1 times 10 is 10. We're then going to write down the factor pairs of 10. So we've got 1 times 10. We've also got 2 times 5. But what pair, yes, they multiply to 10, but what pair add to give us 7? Well, it's going to be 2 add 5. So we're then rewriting our expression and splitting up this 7x into 2x plus 5x. So x squared stays the same. 2x plus 5x plus 10 stays the same. Split that expression straight down the middle and factorise both of these halves using a common factor. So first half, take out x as your common factor, so x bracket x plus 2. And then your second half, 5 is your common factor, so 5 bracket x plus 2. We now need to identify our brackets for our final answer. So you've got x plus 5 as your first bracket, and then x plus 2 as your second bracket. And just rewrite those, and that's the final answer. So well done if you got that. Okay, third example. There's 4 examples in total. This time we're going to be factorising x squared plus 11, x plus 24, always following the same steps. So our first term multiplied by our last to give us 1 times 24 is 24. Then we are writing down the factor pairs of 24. So we've got 1 and 24, we've got 2 and 12, 3 and 8, and also 4 times 6 gives you 24. But what of these factor pairs, yes, they multiply to give us 24, but what pair add together to give us 11, which is this middle term? Okay, so 1 add 24 is 25, it's not going to be that. 2 add 12 is 14, but 3 add 8 is in fact 11, so that is the factor pairs that we're going to be using. We're then going to rewrite our expression, splitting up 11x into 3x plus 8x to give us the second line. Remember, x squared stays the same, 24 stays the same. Split that expression straight down the middle, factorise the first half using a common factor, so we're going to take x outside of our bracket, to get x bracket x plus 3. And then we're going to take 8 outside of our brackets for the second half, 8 bracket x plus 3, making sure that these two brackets are the same. If they're not the same, then you've made a little mistake somewhere. Then identifying our first bracket, which is x plus 8, and then our second bracket, which is x plus 3. Then rewrite those brackets, and that is your final answer. So this time, this example is all about the fact that there could be several factor pairs for the number that you're looking for, but you need to identify the pair that add together to give you this middle term. So with that in mind, can you pause the video here and factorise x squared plus 8x plus 12? Okay, so multiplying your coefficient of x squared by 12 to give us 12, then writing down all your factor pairs of 12. So you've got 1 times 12, 2 times 6, you've also got 3 times 4. But what pair now add together to give you this middle term of 8? Well, 1 add 12 is 13, but 2 add 6 is in fact 8, so that is the factor pair we're going to be using. So rewriting this expression by splitting up 8x into 2x plus 6x, x squared and plus 12 stay the same. We're then splitting this expression straight down the middle, factorising the first half using a common factor, and then factorising the second half using a common factor. And then we're identifying our first bracket, which is x plus 6, and our second bracket, which is x plus 2. And then rewriting those brackets to get x plus 6, x plus 2. So well done if you got that. Okay, we're going to move on to our last example. But this time we have a coefficient of x squared, so the number in front of our x squared, which is greater than 1. And we're just going to see how this works. But again, we're always just following the exact same steps. So we're going to multiply 2 by 5. So multiply them together to give us 10. We're then going to write down the factor pairs of 10. So we've got 1 times 10. We've also got 2 times 5. But which of these factor pairs add together to give us 11? So yes, they multiply to give us 10, but they now need to add together to give us 11. And it's going to be the first one, 1 add 10. So rewriting this expression, splitting up 11x into 1x add 10x, so our 2x stays the same. Then we've got plus 1x plus 10x plus 5, splitting it down the middle, and we're going to factorise the first half using a common factor. Common factor is x, so taking that outside the brackets, x times 2x gives us 2x squared, then x times 1 just gives us x. And then we're going to factorise the second half using a common factor. Our common factor is 5, so take that outside of our bracket. 5 times 2x gives us 10, 5 times 1 gives us 5. Then we can identify our first bracket, which is x plus 5, and then our second bracket, which is 2x plus 1. And write them out, and that is your final answer. What I should have mentioned at the start as well is that it doesn't matter if you have your brackets round the other way. So if you have 2x plus 1 in the first bracket and x plus 5 in the second bracket, it doesn't matter which way round they go. Okay, so if you can pause the video here and factorise 2x squared plus 9x plus 4. Okay, let's go over the answer for this one. So multiplying the coefficient of x squared by 4, so 2 times 4 gives us 8. We're then writing down the factor pairs of 8, so 1 and 8, 2 times 4. But which of those pairs add together to give us 9? What's going to be the first step? So we're going to rewrite our expression, splitting up this 9x in the middle into 1x plus 8x. So get 2x squared plus x plus 8x plus 4. Splitting that straight down the middle, factorise the first half using a common factor, so you should have x bracket 2x plus 1. Factorise the second half using a common factor, 4 bracket 2x plus 1. And now we can identify the first bracket, which is x plus 4, and then the second bracket, which is 2x plus 1. And write it out, and well done if you got that.